So now we're going to start going through the ways in which practical considerations constrain brain architecture in a bit more detail. As a first step, we're going to look at why a complex learning system will be constrained to have a modular hierarchy of condition detection. First, what do I mean by a condition and what do I mean by a module? As we discussed earlier, a complex control system has to detect conditions in the information available to it and associate different groups of conditions with different behaviors. The available information might include visual inputs, for example. So let's think about what a condition would be if you had an array of detector elements like this. Each element is sensitive to the arrival of light at one small region, and some lens focuses visual images on the array. If light arrives at one sensor, indicated in black, that can be regarded as the detection of a condition, that there's illumination at that one place. If a line of sensors detect light, that's a more complex condition, defined by the set of sensors and the arrival of light at each one of that set. So the complex condition is defined by a set of simpler conditions, and the more complex condition is detected if all those simpler conditions are being detected. A condition can be defined in a way that it's detected even if not all its component conditions are detected, if just a significant proportion are present. For example, the line condition might be detected even if one element was missing, and that could be any element. Then we can go on to define even more complex conditions that are combinations of the complex conditions, like a triangle condition defined by 3 line segments with corners that coincide. So, to summarize these thoughts, a condition is defined by specifying a group of inputs and a state for each input, like the pixels we talked about. An input could be binary, in other words, it just has an on state and an off state, or it could have a range of different possible states. In the simple case, the condition is only present if all the inputs are in the state or states specified for the condition. A slightly more complex definition would be that a high proportion were in their specified states, but some weren't. Now, an even more complex definition would be if each input has a different weight, and if the inputs that are in their specified states have a total weight that exceeds some threshold, the condition is detected. Higher level conditions can be defined by groups of simpler conditions. But a higher level condition could also be one input to a simpler condition. In other words, things could go backwards. So the definition of condition is actually fairly complex, and conditions are defined so that they are useful to a system. A condition has to be some information situation that indicates that some behaviors are more appropriate than others. But a condition doesn't necessarily correspond with some situation that can be neatly labeled in cognitive terms. In other words, a condition may not correspond with the presence of a cognitive category that we can name. One individual condition might sometimes be detected when looking at any one of a number of different categories, and it might not be detected every time you look at an object in one particular category. So defining what exactly a condition detects in cognitive terms could be very complex. The only useful way to think about a condition is that it's an information circumstance that's useful to the system for performing generally lots of different functions. So, we've talked a bit about how conditions are defined. What do I mean by a module? If you look in a dictionary, you'll find that modules are defined as parts of a system that help you build or analyze the system. The problem with this definition is that for a computer, the different applications could be regarded as modules, and the physical information processing components could also be regarded as modules. There's been a long-standing controversy in cognitive science over the existence of modules, where a module has been defined as a unit of resource that corresponds with a type of behavior. In other words, in the computer example, a physical information processing resource that performs one application. And as we'll see, modules of that kind are very unlikely to exist. In computer science, the term module is reserved for the unit of information processing resource, and that's how it's going to be used in this course.